Hello everyone, warm welcome. I'm Dr. Ravi Kumar. So we are having a mixed mode of conference of online and offline. We are expecting other 4 more offline participants also to join. So we will first complete off the online thing, and then we will go ahead and start with the offline sessions as planned. So as the technology shows that the integration we get to involve offline participants and online participants at one place. So this conference is happening offline in Chennai in India. So this is about, so just to brief about the organization, IRF Research Forum in association with ASAR and other research fora and many more are conducting this virtual conference and mixed mode of conference, actually physical and virtual over here. And the organization is a decade-old organization, and then the progress with respect to the organization's numbers, a few figures, if I want to name, right? It's about the organization has conducted more than 700 plus conferences, and then across the globe, and then the participants, more than 1 lakh people have been associated in this journey, and more than 50,000 research papers has been published in the journals. And the organization has around 10 plus international reputed journals, which has been indexed in many places also. And we also have an MOUs and the understandings between a memorandum of understanding and signing between the top publishers like Springer and elsewhere also. So this is a reputed organization which is doing and conducting conferences and publishing papers and doing getting the setting up international platform for all the researchers and getting them together in one platform and having a collaborative environment out here. So with this, we can quickly go ahead and start with today's session, right? So before that, let me take one group photo of an online thing over here, right? So request everyone to kindly turn on your video. Please do turn on your video. Before starting the conference, we'll quickly have a group photo. Thank you.
Hello everyone. My name is Prarthana and I am from PES University, Bangalore. Today I'll be presenting my paper, Smart Indoor Navigation, a Modern Approach. My co-authors for this paper are Pushpal, Snigdha, and Natasha. Here is a quick outline of what we'll be going through today. I'll introduce you to the problem at hand, the work done in the related field, followed by the architecture and functionalities, and to conclude with the results and use cases. In this paper, we look to provide the users with a network-enabled indoor navigation service, which is an environment-specific navigation help using map-like mediums over the local store network. The main objective of this was to explore an alternative to the GPS service in order to provide accurate information in indoor venues like stores and malls. Supermarkets and other giant indoor environments, they're very complex with numerous aisles and sections, making it challenging for its users to efficiently locate and navigate through the store. GPS isn't suitable for such navigation because GPS works through signals and there is signal blockage and reflection, and there's also low signal strength. The signals, they get transmitted from satellites and they cannot penetrate solid buildings or other structures, leading to weak or no reception at all. These signals, they get reflected from buildings, leading to inaccuracies also. Our solution design consists of a customized store service, and each store can have its own store-specific layout. The research aims to exploit well-established networks, which are now available at most venues, and we will use it to deliver customized services. Looking back at the work which is already done in this field, Tan et al. Had proposed an indoor positioning system for navigation, but this was specifically designed just for shopping malls. He utilized signal strength and the angle of arrival measurements to determine the user's location accurately. Next, Khan had developed an indoor navigation system for the visually impaired, where he had incorporated audio and haptic feedback to guide them through various indoor environments. All of these are part of a bigger puzzle, which we have tried to fit into our enhanced system. While these previous studies, they have made significant contributions to the field of indoor positioning and navigation, our proposed research aims to combine these technologies to cater to the needs of the navigation challenges faced by customers in supermarkets. Our research aims to provide an architecture for an end-to-end solution for enhancing and adopting the various pieces of puzzles which has already been worked on before by integrating a network-based navigational service with, let's say, user-friendly maps, visual assistance features, drop-down checklist functionalities. The service seeks to provide a comprehensive and tailored solution, which can be scaled up to support multiple users and replicated across multiple stores. Some of the key factors or points to be noted here are that the store is auto-recognized through the network that the user gets connected to upon entering. The user is provided with an easy, login-free access to the store's website. We have incorporated efficient pathfinding algorithms and additional features like visual assistance and implicit user feedback, which have been added to improve the store layout and product placements. Coming to the architecture of the system, it consists of a dedicated network infrastructure, which is set up within a physical store, enabling various devices to connect and communicate with the store server locally. The store server provides two parallel services. One is a database server, which acts as a backend server, and the next is a app server, which provides the user view. The database server has the entire store's metadata and logs stored in it. There is also an admin interface, which is provided for the store owner so that he can monitor the different user trends and behaviors, and later on run analysis on this to this data, which is obtained anonymously and implicitly. This can be used to improve and improvise on the item placements and other merchandising. The server can be used in any kind of indoor environments, let it be a mall, a parking lot, or an university. To simulate this supermarket for the purpose of the research, we came up with a map generation, which represents an intricate network of maze-like store offerings, which has a lot of sections, aisles, and items. As you can see, there are two kinds of nodes. One are the red directional nodes, which are strategically placed at points where customers can choose from multiple paths. On the other hand, we have the green access nodes, which represent access to particular aisles and sections within the store, serving as the destination points for the customers. While designing the store, several factors were taken into consideration. The nodes were strategically positioned at decision points where customers may need to choose between different paths. By doing so, we gave them an offering of multiple route options and providing flexibility and convenience. To generate this optimized routes, we utilized an enhanced version of the Dicestra's shortest pathfinding algorithm. And by taking into account the aisle congestions and assigning weights to these edges and nodes. So the enhancement, it was made to support the multi-point shortest path generation with positive edge weights in a two-step technique. So firstly, what was done was that a set of access points were generated and arranged in order of their occurrence from the customer's position to the exit. Next, these points were fed into a pathfinding module in pairs to include the default start and endpoints. Each of these edges was assigned a weight which represents the distance and the effort required to traverse from one node to another. These weights took into account factors such as the length of the path and the potential obstacles or congestions that may affect the navigation. Now, this is a heuristic-based algorithm where priority was assigned to each node to decide the order of the stops. Now, let us say that the store owner or the store provided us with 100 notes, numbered according to their convention. The first step would be to renumber these notes, which may not have been done accurately. And this is where the heuristic comes into picture. The heuristic is the node's distance from the exit node, and in case there is a conflict, then the distance from the entry point is chosen to number the nodes. Another useful functionality added is the ability given to the users to make edits on the go to the checklist, which renders an updated guidance system each time. Talking about a few other functionalities, this is a network-enabled service which consists of APIs hosted by the server, providing robust and reliable systems where users can log into indoor networks to find maps and its details. For example, an indoor network for a store could consist of the store stock, the list of items available in the store. Whereas if it's a parking lot, it could consist of the parking layout of the parked cars or wheelchair access points, etc. Next, we have the visual assistance module, which is going to allow users to locate themselves or explore around. Techniques like computer vision was used to help locate lost customers. In such cases, the users can utilize this visual aid feature to scan the nearest item in their vicinity and retrace back to where they needed to be. Finally, we have an implicit user feedback system, which dumps anonymous user data to the server. With the valuable insights obtained on analysis, the user behavioral data, store owners can maximize their profits by finding out the hotspot areas, busiest parts, and the customer shopping trends in the store. This offline feedback unit allows the system to receive and store user feedback even if the user's device becomes disconnected from the server, as this is the data exchange is occurring internally, ensuring that even if the user disconnects, the data is not lost. This also eliminates the need for multiple exchanges between the client and feedback analysis module, which streamlines the process and enhances the efficiency. By the end of this research, we had arrived at a few conclusions. A comprehensive study was performed where the performance of various algorithms was compared as a function of the number of nodes against the time taken. So as you can see, three algorithms were compared here: the Dijkstra's algorithm, the Bellman-Ford, and the Floyd-Marshall algorithm. The table here shows the relation between the time taken by the different pathfinding algorithms with the increasing number of nodes. The Dijkstra's algorithm shows standout performance and is thus chosen to find the shortest path between the two nodes in a graph with non-negative edge weights. It is more efficient than the other two when dealing with sparse graphs, where the graphs are present with relatively fewer edges compared to the number of nodes. The Dijkstra's algorithm is achieving this efficiency by using a priority queue to greedily select the next node with the shortest distance from the source. So this system, at the end of the research, we concluded that the system can be scaled horizontally to support multiple users, and it is also adaptable to the different customized maps for each store. The store dump is being collected anonymously and internally, making it reliable and secure. We also have made it robust and fault tolerant to other network failures. In the future, we'd like to incorporate and provide real-time product availability updates and recommendations based on the shopping history and other online platforms. Additionally, we would like to incorporate computer vision techniques that can be employed to recognize and track products on the shelves, enabling the system to assist users in locating specific items more efficiently. Some of the use cases of this could be in indoor environments like grocery stores, retail stores, clothing stores, universities, malls, smart city projects, museums, and industry facilities. The image here on the right shows the entire map of how the customer's journey through this. The customer would first connect to the store's local network and scan a QR code to get into the website. Upon entering the website, the user is provided with a lot of functionalities such as adding items to the cart, getting directions, the shortest path, just exploring the map and the and the local store. He has a visual aid feature which will help him if he's lost. And insights are also provided to store owners, which is an added advantage. That's it for my end. Thank you, and I'll be open to.
Warm morning to all panel members. We are students of Coimbatore Institute of Technology. We are currently studying second year MSc Data Science, and we are here to present our paper on phishing detections using AI model. Myself, Tarani, and I will be giving an introduction about our paper. Let's get started. In the ever-expanding digital landscape, the prevalence of phishing websites poses a substantial cybersecurity threat. Our research underscores the critical importance of these malicious sites, which exploit the various tactics to deceive individuals and comprise sensitive information. The stakes are high, ranging from identity theft to financial fraud. To address this pressing issue, our paper focuses on developing an effective detection model. Leveraging a robust dataset comprising both phishing and legitimate URLs, we employed the random forest algorithm coupled with NLP based features. Our research has achieved a remarkable 97.99% accuracy in detecting phishing websites. This highlights the effectiveness of our approach in strengthening cybersecurity against the rising threat of phishing. Now, I will pass it on to our team members who will delve into the specific details of our methodology and findings.
Your team members are not unmuted, I believe.
Good morning, sir. I am Ramesh. There are some challenges in identifying the phishing websites, sir. The first thing is the defective web addresses. This is a very companies users activity in making it challenge for users to distinguish between the real and fake websites. Suitable misspellings, extra characters, or common techniques employed by the social engineering tactics. Phishing uses persuasive and emotional.
Dhanush, sorry to interrupt. There is some network lag.
Challenging languages to manipulate users into taking actions they own
There is some network
normal
issue.
case. They create a sense of urgency.
So I believe there is some network issues from Dhanush ends. Tarini, would you like to go ahead and continue? Tarini, would you like to continue? I believe there is some network issues from your partner, no, from your teammate side.
Hello, can you hear me,
Yes.
sir?
Yes, we can hear you now.
There are some challenges in identifying the phishing websites, sir. The first, defective web addresses. Phishing websites often use URLs that phishing websites often use URLs like that closely mimic legitimate websites, making it challenging for users to distinguish between the real and fake websites. Suitable misspelling, extra characters, or slight variations in domain names are common techniques. Next is social engineering tactics, visual impression, email and messaging scams. You know about it, I think so. HTTP usages, An increasing number of phishing websites uses HTTPs, making them appear more secure. This can mislead users into thinking the site is legitimate, as HTTPs is commonly associated with secure, trustworthy websites. Our teammate will continue it.
Good morning, sir. Today, in this session, we are going to discuss about the proposed systems. First of all, there are four proposed systems in this paper which we have researched for. First one is feature extraction. The feature extraction stage involves processing the collected URLs to create relevant features that the AI model can use for distinguishing between phishing and the legitimate sites. Here, the legitimate sites is the proper, the real websites. Real websites. In the proposed system, two types of feature sets are utilized. That is NLP based features and word vectors. Here, that is feature extraction is nothing but just comparing the both phishing and legitimate website to train the AI model. Next comes the testing the classifier. That is the final stage assess the performance of the trained AI classifier. This is achieved by evaluating its ability to correctly classify the URLs as either phishing or this is achieved by evaluating its ability to correctly classify URLs as either phishing or legitimate. Next comes the data collection. In this stage, the system gathers a diverse data set of both phishing and legitimate URLs. The data set is essential for training and evaluating the AI model. Data collection comprises two main components. That is, first one is collecting phishing URLs, and the second one collecting legitimate URLs. The next is training the classifier. With the feature extraction complete, the next step is to train the AI classifier. Various machine learning algorithms are employed for this purpose. In this proposed system, 5 classification algorithms are used, such as naive-Bayes, logistic regression, decision tree, random forest, and support vector machine. Actually, the first step involved in the proposed system is data collection. Next is training the classifier. Training the classifier is we have to put the both the URLs of legitimate and the phishing web URLs together, such that to train the class AI model. Next is feature extraction, which is that is comparison of both the features of phishing and legitimate website. That is, both of them may have similar name, similar feature, and similar code, and everything will be similar. So that we users get confused with the legitimate and the phishing websites. Next, the final stage is testing the classifier. Now let us look into the data collection in detail. First is collecting phishing URLs. Several public and private sources maintain database of known phishing websites. That is, for example, we can consider a service called Fish Tank. Next is web crawling. Web crawling method is also known as web scraping, which is used to get the URLs of the legitimate website. That is, researchers or organizations may use web crawlers or web scraping tools to discover phishing websites. These tools simulate the browsing behavior of users visiting various web pages. That is, some phishing URLs are reported by internet users who have encountered them. These reports are valuable as they often lead to identification of new phishing websites. Next comes the APIs and service. Some services such as Virus Total and Google Safe Browsing provide APIs that allow researchers to fetch information about potentially malicious websites, including phishing URLs. The other ways of collecting legitimate URLs are web indexes, data providers, and public resources. Web indexes is nothing but just searching in the as usual searching in the websites. Next is with the help of the data providers, and the third one is with the help of public resources. Next is and the other methods for data collection include manual collection, automated web crawling, API integration, user reporting, and structured data storage. First of another main thing is some of the phishing defensive methods include there are two types of phishing defensive methods, that is through user awareness, and second one is through software based detections, in which software based detection is divided into various categories. First is list based detection, next is deep learning based detection, and next is machine learning based detection, and so on, which I think hybrid method will be the last. And these methods uses various machine learning and deep learning techniques such as CNN, RNN, and various methods to scan through the phishing URLs and make the users prevent from going through it. Next is some of the feature extraction. As I already said, feature extraction is nothing but comparing both the legitimate and the phishing website. Here, with the feature, here there are two types of feature extraction techniques. First one is NLP based, and the second one is word vector. In NLP based, we can see that both the phishing and the legitimate websites may have similar IP address and similar company name. For example, if we consider Kotak Mahindra Bank, the legitimate website may contain the name as KOTAK, whereas the phishing website may contain COTAK. Next, and the various methods are Alexa check, randomness check, special character check, domain digits, file path digits, word count, word length, and length of the longest word, and many more. Next is let us get into the word vector. Count vectorizer in Python. Count vectorization in Python is a technique that transforms text data into numerical vectors. That is, this converts the text into binary form. It counts the frequency of words in the URL and creates a vector of word counts. This method is limited to a set number of features such as 300. That is 300 will be the maximum limit. Next is string to word vector in WEKA. That is, in this approach, URLs are converted into word vectors using string to word vector module in the Veka machine learning software. Veka is nothing but a machine learning software. Initially, this method generates nearly 1,600 features, which are then reduced using feature selection techniques. Next, here comes the training the classifier. This is nothing but, for example, if we consider the machine learning technique, we use CNN to train the model, and some of its importance and description are mentioned here. First one is Naive Bayes. Naive Bayes is known for its speed and simplicity. It is often used for tasks involving natural language processing and text classification. In the context of phishing detection, it can be used to classify URLs based on the probability that they are phishing sites. And its description is naive Bayes is a probabilistic classification algorithm based on Bayes' theorem. It assumes that the features used for classification are conditionally independent, which why it's called naive. It's simple yet effective for text classification tasks. Now, my friend Sandhya will continue the talk.
Good afternoon, sir. Myself, Sandhya. I'm going to explain the rest of the AI models algorithms we have created. So, decision tree. The decision tree is a tree-like model of decisions and their possible consequences. As we know, a tree contains nodes which contains data, but in our AI models algorithm, the tree's nodes contain the decision and their consequences in their nodes. So basically, we will be having all the data present in the root node, which will be further divided into child nodes based on their informations and similar categories. So our basic idea is to create and form the leaf node, which is the class label. So it recursively splits the data set into subsets based on the most important feature at each node. Aiming to create the leaf node is the decision tree's aim, sir. So basically, the importance of the decision trees are intuitive and easy to interpret. They can be used for feature selection and identifying most informative features in the context of phishing detection. The next one is the random forest. The advantage of random forest over decision tree is it can contain the aggregation of decision trees, various decision trees. That is, in case of decision tree, we will be facing the problem of overfitting, which will also include the noise and other environmental sounds. But in case of random forest, it will reduce the redundancy as well as the overfitting problems. Therefore, random forest is more advantageous when compared to decision tree. It will also, as it also holding the aggregation of their predictions, it is helpful in handling the high dimensional data. Next comes the supportive vector machine. Supportive vector machine is similar to the random forest, but in case of supportive vector machine, we will be handling in both linearly and in a non-linear approach. So these were the 5 AI models we have integrated, sir. So this is the graph we have analyzed. So in the first case, we have the algorithm naive-based algorithm, which is integrated with NLP-based, which only produces 69% of accuracy. In case of naive-based algorithm integrated with word vector, it holds 84.33% of accuracy. In case of logistic regression integrated with word vector, we have 92% accuracy. The same when it is integrated with NLP based, we have the accuracy of 93%. So we can see from this graph, a random forest when integrated with either NLP or word vector will produce the most accuracy. So we will be going on with a random forest integrated with NLP based, only providing the highest accuracy of 97.99%. So this is our conclusion, sir, that we can integrate random forest algorithm with the NLP based features in order to get the 97.99% of detection of phishing URLs. So some of the key findings in our proposed systems are higher accuracy, effective machine learning algorithms, NLP based features, real-time detection, and overcoming traditional approaches, sir. So higher accuracy, the system achieved an impressive accuracy rate of 97.99%. In case of effective machine learning algorithms, the study evaluated 5 different machine algorithms, namely naive-based, logistic regression, decision tree, random forest, and SVM. NLP-based features, we can identify either with the similar company names or IP address. As said, IP address, when we share any YouTube link, it will also hold its IP address. So the third party can access our information with that particular IP address. For that, they will be only having a ad. If we touch the skip ad or continue ad button, we will be allowing the access to them to access our information. So in this case, NLP-based structures are useful. And in real-time detection, this is designed for real-time phishing website detection, sir. So our conclusion is deep learning integration, larger and diverse data sets, real-time analysis, human and computer interaction, and mobile and IoT security. In case of deep learning and integration, we would be using CNN and RNN. CNN is convolutional neural networks. That is, in case if we want to study a whole page, CNN would be splitting the whole page into small parts, and it will be reading and evaluating the small parts separately, and then it will provide a overall conclusion. In case of recurrent neural networks, our computers, after reading some information, when moving on to the next information, it will be forgetting or just ignore the previously read information. But in case of recurrent neural networks, it will be holding all the informations in its memory. That is, for example, if we just specify as my cat, it will identify that it's something going to be read about the cat. So using these neural networks, we will be having all the data sets to recognize intricate patterns in URLs. In case of larger and diverse data sets, we will be having all the up-to-date phishing and legitimate URLs, enabling us to improve the generalization and to adapt to emerging threats. In case of real-time analysis, our algorithm had provided 97.99% accuracy, but in our future work, we would be also reducing the time complexity. That is, even in a short amount of period, the phishing websites could be differentiated from the legitimate URLs. What human-computer interaction is about is to differentiate the phishing and legitimate URLs not only by the computers, but it is also helpful for the humans to identify it in an easy manner. In case of mobile and IoT security, we would, as we are in the increasing the use of mobile devices and IoT things, extending the system's capability to protect these phishing system attacks from these platforms from phishing attacks is crucial. So these are the conclusions and future work. So our promise is to even reduce the time complexity in our future work, sir. Thank you.
So you can see that the parameters over here is engine size, cylinder, number of cylinders, and fuel consumption. So when we predict it, it shows what model we have selected, what the closest prediction is, and what the error percentage is. So you can see that over there. So the error percentage for this is around 2.57. So we can change the parameters. Here the error percentage is 2.35, and the model selected is linear model. So other than this, we also have a fuel efficiency like chart. So we can select what company you want to select, and then it will give you the data for all the models that are there, along with the fuel consumption for these models. So based on this, the user can select what yeah, so yeah, so you can see what model is giving the most fuel efficiency here. So based on this, the user, like the person can select what car they want to go for. So other than this, we also have a compare page where you can select the company's name Then we can select the model. You select the model and then then when you compare it, you get the fuel consumption. Other than that, you get the CO2 emission from them. Then even the engine size, cylinder, all the technical aspects will be displayed in this. Stop sharing.